So that awful handwriting that you see on the board was because I did that on my computer while you guys were working. These are the basic steps. So you'll notice that this already has the space that we need. So I didn't have to do anything. I could go straight to dividing everything by the 1 and then do the cycle. So you take the negative 18 divided by 2 and it gives you negative 9. Would you stop? No, I'm just kidding. Bless you. You take the negative 9 and then you square it and it gives you a plus 81. You take the plus 81, multiply it with the 1, and that still gives you plus 81. So when you combine the like terms over here, negative 72 plus 81 gives you 9. And then, like usually, there's a number in front and you have to divide by that, but when it's just the 1, you don't have to do it. When you divide by 1, it's the same thing. So then the next step is to square root both sides. Anytime you square root both sides, you get a plus and minus answer. And the square root cancels the square, so the x minus 9 is now regular. So then you just plus it to the other side. I didn't split this up like I did yesterday, but it is 9 plus 3. So that's how I got 12, and then 9 take away 3, so that's how I got the 6. So when you get nice answers like that, where there's no radicals involved, that just means it could have been factored in the first place. So if I would have like added the 72 to the other side, so it's equal to 0, the factors would have said x minus 12 and x minus 6. When you get radicals, that just means you can't factor it. So that's why we have to have the quadratic formula, because not everything can be factored. So I have some really easy stuff for you today. It ties into the prison stuff from yesterday. Remember how we broke out the stuff? We're going to learn how to add, subtract, and multiply things that have radicals in them. So I have, well, we're going to do that. We actually have 3 things that we have to do. There is a rule that says we're not allowed to leave radicals at the bottom of a fraction. And I've showed you this before, but I'm going to show you it again because it's now it's official. It's going to be on the test. So first, I'm going to talk about adding and subtracting, and we're going to kind of clump them together. When you add and subtract, it's really important that you simplify the radicals first. And the reason why is because adding and subtracting works like kind of like this. The only time you can add and subtract is if they're like terms. So this is true with radicals also. If I have a radical that says 2 radical 5 plus 4 radical 5, you are allowed to add these together. Now when we add them though, we don't touch the 5s. Just like when we add x's, they don't become x squared. So all we do is we use the numbers in front. So that's true for both adding and subtracting. So if you have a problem that doesn't match, it's probably because you can break it down and simplify it. Once you simplify it, then they should match. So it says, let's see, simplify each radical, combine the terms having the same exact radical. So that's the like terms example I gave you up here. So when it says to combine the coefficients, that's when I said just use the numbers in front, and then the radical doesn't change. This is the big one that people mess up on sometimes. Radicals don't change when you add and subtract. So I found some notes that someone had on the internet. It says right here, adding and subtracting is very similar to adding and subtracting like terms. So you can see this example right here. When the radicals are exactly the same, you just use the numbers in front, and you end up with 5. And then you just reattach the radical 7. Now, if you get a problem where the radicals are not the same, you should try to break them down. So like if I took 7 and try to break that down, 7 doesn't break down. It's just 1 and 7. So that would just stay at 7. The other one is 6. So if I tried to break down a 6, I would break it down into 2 and 3. But the problem again is there's no pairs. So remember, this is a 2 right here. So I don't have matching numbers to break anything out. So this would actually be the answer. You can't put them together. And so you would just leave them as 2 separate terms. And very rarely are we going to give you problems where you can't do anything and the question is the answer. So we will give you stuff where you will have to break down and they will match. So a couple of quick examples of that. Let's see. The quick examples are the ones where they're ready to go. So you can see they both have the 3's inside. So we just use the numbers in front. Also, this is a minus question. Minus is treated the same way as plus. So you just use the numbers in front. -4 and -5 makes -9. And then we just reattach the 3. So that would be the answer. Now when you guys look at the other one, you can kind of see that one is not really going to work. So we have to do some stuff first. So we have to break down the 20, we have to break down the 180. So let's take a look at how to break down the 20. The 20 has a 6 in front, so right away I'm going to put 6 times. Because whatever comes out has to multiply with whatever's in front. So if I break down 20, 5 times 4, and then 2 times 2. So according to what we learned yesterday, there's a little 2 right here in that little step. So I've got a pair of 2's right here. So a 2 is going to come out with a 6, and it's going to be 6 times 2. And then this 5 is left over, so that goes back in. So that's the first part. And guys, I'm going to tell you a big secret. I don't know if this is like if this was a video game, this would be a cheat code. We know that they have to match, right? So I bet you anything, this is 5 times something. It has to be. Because we know that the only way you can add them is if they match. So it's got to have a 5 in it. So 5 times what gives us 180? What is it? 36? And then we break down the 36 into 6 and 6. And I'm actually going to stop there. I know that 6 and 6 breaks down more, but you got to think about what our goal is. Our goal is to make the numbers match. They already match, so I'm going to stop there. I'm going to use that to take it out. So the 6 comes out, the 5 goes in, and this was a plus problem. So now we can combine like terms, but I have to simplify this first. So 12 square root 5 plus 6 square root 5 would give me 18 square root 5. So that would be our final answer. So when it comes to adding and subtracting, the radicals have to match. If they don't match, we have to break them down. And when you break the first one down and you see what's left, you can actually use that to help you with the second one because we know they're supposed to match. So that means the second one should have a 5 in it. So that's how you add and subtract. What do you guys think so far? Not too bad, right? So what you guys are going to have to keep straight is the rules for multiplying are a little different. And they always have been. When we add, the x's have to match. That's called like terms. Same thing when you subtract. But when you multiply, you can actually multiply anything. They don't have to be like terms in order to multiply. So what we're going to do here, the rules for multiply, it says multiply the terms that are on the outside of the radicals, and then multiply the terms that are on the inside of the radicals, and then simplify the radicals. So basically, here's what we do. We take the number in front, and we multiply it with the number in front. So -4 times -3 is -12. Then we take the number on the inside, and we multiply it with the number on the inside. So 5 times 15, is that 75? So we get 75 in here. And after we multiply, we have to try to break down the radical. And guys, breaking down 75 is easy. It's going to be 5 times 15. Because that's what I multiplied to get to that. So it's easy to break down. So then this one right here is 5 times 3. This is blank again, which means it's a 2. So we're doing these in groups of 2. So I've got the 2 5s right here. So a 5 needs to come out. A 3 needs to go back in. And then we have the -12 in front already, so that has to multiply. And guys, the reason why we're multiplying is because there's no sign in between the -12 and the 75, so this means times right now. So if anything else comes out, it has to multiply. So that gives us -60 square root 3. Okay, so if you take a look at the next example, you're going to notice it's got a set of parentheses. So you're going to have to take this problem and distribute it. Same rule, it's just you got to do it twice now. And then you got to see if they break down, and if they break down, then we got to see if we can add them. So the first one, 2 radical 3 times radical 2. When you have a radical with nothing in front, it's like having a 1, just like when you have an x. So it's 2 times 1, that's 2. Radical 3 times radical 2 is radical 6. And then the second one, 2 times 5 is 10. Radical 3 times radical 6 is radical 18. Now because this problem has a plus in it, we have to see if we can break it down and actually add it. So if I was going to break down the 6, what do you need, number 3? Oh. If I was going to break down the 6, it's just 2 and 3, so that doesn't help. If I break down the 18 has a 6 in it. It's going to be 6 times 3. And this right here is going to be, what is this? 2 times 3. So we can take out this 3, and there's already a 10 in front, so it becomes 10 times 3. We have a radical 2. So 10 times 3 is 30, the radical 2 on it, and then 2 radical 6. Now, unfortunately, in this problem, the radicals don't match, so we can't put them together, so our final answer has 2 parts to it. And that's going to happen from time to time. So you should just get in the habit, anytime you multiply, see if you can break it down, because we expect them in the most simplified form possible. So in your mind, you're going to have to come up with a way to remember that adding is only adding the fronts, multiplying, multiply the fronts, multiply the inside, and then break down. Okay, the last thing I have to show you is how to fix having a radical at the bottom. For some reason, when we have radicals, a lot of these radicals are irrational numbers. That means that they're these real long decimals. And we don't like having them at the bottom. So the easiest way to get rid of it is to take whatever is on the bottom and multiply the problem on the top and the bottom by that. So what I mean by that is we don't like having a radical 10. So if I want to make the radical 10 go away completely, I just multiply it by radical 10. Because if I multiply radical 10 times radical 10, that's radical 100, which is now just 10. So here's how the work's going to look. So we're going to always multiply by whatever radical is on the bottom. Then using the rules that we just learned, that's a 1. We can now multiply this stuff. And this is what we would end up with. And guys, usually when I do this stuff, I actually skip this step right here. I don't put radical 100. I already know radical 10 times radical 10, the answer is just 10. But they showed it, so I'm going to show it to you. So then we have to simplify. The thing is, once that 100 turns to a regular 10, you can now simplify anything that's not in the radical. So this is like having 5 over 10. So 5 over 10 reduces to 1/2. Now, not everything is going to reduce like that, but it's something that you do need to check for. So your final answer would be this. And the weird thing is, you guys, is if you put this in the calculator, it does this for you. Like, it'll do all the work for you. I said it will do all the work for you. Okay, so down at those are the 3 things I needed you to learn today. Number 1, adding and subtracting, make sure they match. If they don't, break them down, then just add the fronts. Multiply the fronts, multiply the insides, break them down. This, by the way, this is called rationalizing the denominator. So basically that means we can't have radicals at the bottom, so you just multiply the top and the bottom by that same radical and then simplify it. The last thing I want to just bring up, because it's in your assignment, I want to review what some of this stuff means, because we haven't talked about this very often since like probably chapter 1. So what does this mean? When it tells you to do this. Oh my God, I messed up. I don't want the S twice. Go like this. What does that mean? Yeah, it just means like somewhere above, they're going to tell you what f of x equals and what g of x equals. So they're telling us, take those 2 problems, plug them in, and just add them up. You're going to get a question like that on your homework today. How about this one? F of g of 3. Okay, so I'm gonna list it as steps. 1, plug in g of 3. And then? So number 2, plug answer from step 1 into F. Oh my God, I don't know how to spell F. It's just the letter F. How stupid. I put IF. F. Should have been EF. Okay, so you do this part first, you get this answer, and when you get that answer, then you put it into this one. If you have f of x times g of x, that usually means you have to FOIL. So they're going to be all different kinds. I think on your homework, there's f of x, g of x, and h of x. So you just have to pay attention to which stuff you're plugging in. Oh, I forgot. How about this one? I don't remember if this one's on there, but we should probably talk about it. What if it says this? What does that mean? So basically what this means is you're going to put this entire problem, so let's pretend it says g of x equals x plus 1. So you're going to go into the f problem and take out every single x there is and replace it with x plus 1. So that just means plug the first problem into the other problem for every single x that you see. And that's it, guys. That's the lesson. The assignment, I think, only has like 12 questions. So it should be pretty quick.